All right, everyone, let's come back together. I'm going to go ahead and continue our discussion about core concepts and talk about collecting data on core concepts from participating programs. So this presentation is more of a proposal, and it's something that the planning committee encouraged me to include because we were talking about how we can collect some data to learn about what are we actually teaching in our program. So just to give you an idea of where I'm going with this. This will be a pretty short sort of presentation, and I just want to open it up for discussion at the end. But what would be the purpose for this data collection, and then just showing you how we could do it by using individual faculty course surveys and then doing a curriculum analysis, and then we can have a little bit of discussion. So our purpose, my purpose, of what I'm envisioning for this data collection is that we already have faculty surveys, and Jenny said that about 200 faculty have taken these surveys in terms of what concepts they find are important, although there's quite a lot of variation in terms of what we each think is most important, how we would rank these concepts, right? So these concepts, we all, I would assume, agree are important to some extent, right? But then the ranking, I think, is important for us to figure out, because if we're going to have core concepts included in our guidelines, we really need to maybe consider which ones we want to include. I'm not sure that having all of them, maybe that's what we want to do, but maybe we want to focus on some of them. And Joe Michael was the one who suggested that and said that maybe we want to focus on 5 or so, but it's up to us really to decide which ones we think would be most important. So we also have done student surveys, and Jen Rogers is going to talk about that tomorrow. She'll talk about the data that we collected from students, what the students think is important, which I think is another interesting perspective, right? But I wanted to come back to this figure that Jenny showed you, and I know it's still pretty small here. I tried to blow up things as big as I could, but we were asked to pick 5 from the 15 core concepts, right? That are top 5, not necessarily ranked, but what we think are the top 5. And we came up with structure function. Actually, number 1 was homeostasis. Then cell-cell communication and structure function were the next with 13%. And again, based on those who responded to the survey. And scientific reasoning was up there, and flow down gradients was up there. So those are the 5 that we came up with. Other groups have maybe come up with slightly different lists. This is just what comes up, right? But you see a percentage is assigned to each of the concepts almost, except for, I guess, cell theory. Cell theory, nobody picked that. So I'm not quite sure why that is. So, right. So I just, what I wanted to do is focus on what do we actually teach in our curricula. And for me, that question is a little bit different than asking, what do you think is important? Because this is your opinion. You as one faculty member teaching certain courses, having certain expertise in certain areas, I think you have your own ideas of what's important. But to me, if you're looking at what we teach, that's vetted through a curriculum committee. That's gone through and has been looked at by your colleagues already. And I think it just gives us another perspective. It gives us more information about what we value, I think. I think it also can help us maybe narrow down the list. But I think in addition to that, it can be an opportunity for self-reflection and seeing what we actually have in our curriculum. So I had a very interesting experience in our department as I used this method that I'm going to show you a little survey that I came up with. But this survey, I used it to see if PhysMaps, that assessment tool, would be possible for us to use in our curriculum. And as I presented it, our faculty pretty much were very resistant to it, and just to say the least, right? I think it just wasn't necessarily a welcome addition to our program. It was sort of but why? And why should we do this? Who is it that came up with this? I didn't come up with this, right? I mean, if you think about it, a lot of us sort of have that sort of resistance when someone tells you, well, here's what you should do. This is what you should teach. Most of us go, wait a second, why? And who came up with this? So I think by having that involvement and having that conversation with faculty, that can really help, because it really what ended up happening is with the survey that I used for FISMAPs, there was resistance, but then I asked people to fill it out anyway, and I thank Nick for encouraging them to do that. And everyone did fill it out, and what we found afterwards was the reality was we are teaching all of this. But if you were to just kind of look at the room, you'd say we weren't, because everyone was it seemed there was so much resistance, right? So I think it was sort of interesting, the process, right, to look at that and have everyone sort of go, oh, okay, yeah, we do teach this. Oh, I guess this assessment would be good. So we are going to implement it in the fall, and I have a poster about that, so I can show you that. But my thinking and my proposal to you is that we measure this in our courses, but what we need is a person to take this on at each of our institutions, which is, it's going to be some work, right, to keep track of this and to give the surveys to all the faculty in your group, in your program, and collect all that and put it together. It's not that hard. It's just a matter of actually getting them to do it. And I found that individual emails usually work versus a group thing. But one way that, so what I came up with is a one-page, two-sided survey that lists all the core concepts. So what you have on the left side is the core concept and the definition, and then 3 possibilities in terms of how much coverage. So this is at the high level, not the drill down, unpack concepts, but the high level, just to figure out which are the ones that we tend to focus on in our curriculum. So double-sided, you fit all 15 on there. You have the reference so they can look up the core concepts and read more about it. And you can use this as a piece of paper and just hand it at the faculty meeting, and some people will just fill it out on the spot, read that and fill it out, then you can collect it, or you can do it electronically. We can work it out. We can provide that and figure that out if that works better for you. So just to kind of zoom in on one of these concepts, the 3 possibilities are concept not included in my course. Students are only minimally exposed to this concept, and students are exposed to this concept in significant detail. So pretty simple, and I think most of us can take an inventory of what we teach in a course and think of that and quickly sort of rate it and put a check mark next to each of these boxes for each concept. And for team taught courses, you would have all of the instructors who are teaching that course fill it out, and then you'd compile that, and you'd pick the highest score for each concept, because if one of the instructors is teaching it, it's being taught in that course, right? It's being covered at a certain level, at a higher level, I guess. So this is my actually FISMAPs. I haven't been able to complete it yet because I started this in May as people were leaving for the summer, so I haven't been able to get all that from our faculty yet for the core concepts. So this is FISMAPs, which includes a number of core concepts, but also the vision and change. So 7 core concepts in vision and change. So that's what you see here. And I put this together, and I found I put together the scores. And you can see that out of a score of 30, which would be the maximal score, homeostasis rated 29, right? So a lot of us are teaching that in our courses, in our core courses. So the core courses are the courses that are first 4 courses on the left. Those are core courses that all of our students have to take, but then in the electives, they pick and choose, so not everyone takes all of them. But you can get a score and get some sort of an idea of the ranking of these core concepts and how much of that is being covered in the curriculum, being included in the courses that are part of the curriculum. So that's basically my proposal. I wanted to see if there was interest in that. If those of you that are part of programs, not everyone is part of a 4-year program, but I would say if you're interested in doing that, I think this would be very good for us to learn and for us to put together to use in the national guidelines possibly, and see if we learn some more about which concepts we value. So what I wanted to do is just, these are the 3 of the core concepts that really came out, and they line up with what other groups have found. So homeostasis, cell-cell communication, interdependence. Evolution scored very low in our group.
evolution twice?
Right. So evolution for PhysMaps, it's also listed for vision and change, and it's listed for also for the core concept. So that was repeated. So this is specifically for PhysMaps. I'm just showing you the template sort of that could be used to collect all this. Yeah, just because I don't have that data yet for the actual core concepts. But yeah, the interesting thing is that the definitions were different, a little different. So the score was different for evolution, even though it's listed twice. So that was, yeah.
So I guess I'm curious what the definition is. Do they really know what they're answering?
Right. So the definition is included with each concept. So you would see that in the table. So for homeostasis is the internal environment of the organism. So you have that information there. So yes, you're not getting a lot of detail. You're getting just this part of the concept. And that's what we got when we were rating the concepts as well. Right. So that at that level. So I'm not talking about going down. Do you cover it really to the level that has been unpacked? Because maybe you would change your answer, right? So that is very possible. But at this level of just the definition and that understanding, we got one of the things that I can tell you that really meant a lot to me was that many of our faculty didn't know about the core concepts. And when they heard about the core concepts and that they can get the book free, they learned, they downloaded it and they're learning about it. And now we're having conversations about how to incorporate that in our courses. And I think that is a major benefit, just having that. There's a lot of us in this room are aware of things that, and we're amazed when others don't know it, but they don't go to the same meetings. They don't go to the same. They're focused on their research. They're focused on their work, not necessarily on these resources that are out there. So I think it can also provide that opportunity for engaging with your department and your peers. So. Feedback and discussion. I just wanted to see what everyone thought. Would any of you be willing to take this on and collect this, and then we can use this possibly for the national guidelines to kind of include this information? So we have information from faculty surveys, from student input, and from what we teach. And I think we'll get a better picture, a more clear picture, if we include what we're teaching as well. Can someone help me with the mic? Thank you.
So on your rubric there, green light would help. Okay, sorry. So you had your department courses there, right? Your core courses, top. Right? And I know up on the top. And I know some of the work that Erica and you guys have done with trying to ask, okay, for a physiology program, how many semesters of chemistry, organic chemistry, et cetera. So I guess I'm wondering, would you have to do, if we're talking about curriculum analysis, those foundational classes are part of the curriculum and you would think are covering some of this. And then there's also the physiology specific classes, and then maybe the classes in a department that are still part of the core curriculum, but maybe you don't have physiology in the title. I'm thinking like we have a capstone research class that, might get at some of these things, but isn't going to have that title. So how much information can we glean if we just do the curriculum of upper level courses versus in order to get a clear picture, do we need to also look at those introductory biology, chemistry, organic chemistry, biochemistries, to understand it, because if you included that, then maybe they are getting quite a bit of evolution. It's just occurring in their basic biology and not in the major specific courses. Right.
So my focus was on our program and the part that we control, just trying to grab the lowest hanging fruit, because ideally you would include that, because a lot of those concepts are part of what we're teaching. I mean, without those concepts that they're learning in those in chemistry and in physics, we're not good. So many of us, we bring that back and we bring up those concepts again, but oftentimes we rely on the fact, oh, you already know this, I'm just kind of bringing it up a little bit. So I think that's a very good question and it won't necessarily give us a complete picture without that, but I think it will still give us a good picture of the parts that we can control within our department. I do think it needs to include an introductory anatomy, physiology, or anatomy or physiology, whether they're together or separate.
So along that same line, and it's a great idea that you're doing, to get it into your faculty, to get them more aware of these things. And we begin to talk about in our undergraduate program committee is also telling our students about this.
Yes.
That these are the things you should have by the time you graduate.
Right.
And we'll show them a grid and say, and these are the classes where you can find those things.
Excellent.
So that if you realize, oh, I don't have any of this, oh, I need to try to take that class. All right, now we're only just beginning this whole conversation. We don't know exactly how we're going to roll it out to the students, but it's like, let them know. And particularly when we're talking about employable skills, it's like, make sure you're not deficit in any of these different categories.
Yep. So we started collecting the data, some of this data about the learning outcomes that we have in our program, and we're asking them this on their exit survey, but we're not necessarily doing a lot of this at the beginning of the program, right? So it's the same idea. I think we need to tell them, this is what we're going to teach you, and then this is what we taught you, and did you get it? Right. So I think those are that's a very important thing. In fact, Cindy suggested that I do this table with shaded sort of like a white, gray, and black, so that you kind of just at the glance can see where the emphasis is, which I think would be really, really helpful. I just couldn't get it done in time. Yeah, exactly. Like a heat map. Yeah. That's very good. Yes.
I'm wondering if you encountered difficulty in getting your faculty to recognize that ideas that were important to them were in fact encapsulated in these core concepts. So for example, I've looked at these now. Last year we looked at them, and I've had the book and so forth. One of the things that I focus on is protein ligand interactions and things like affinity and competitive inhibition and allosteric modulation and so forth. And I guess that's somewhere in cell-cell communications, but even if I look at the unpacking, I don't really see it represented there.
Okay.
And yet I think of so many things within the cell and that are dependent upon these types of interactions.
Yeah, and that's what some of the feedback that I got from some of our faculty. They said, well, based on this definition, this is the best I can give you, but I don't know exactly how much. So they're doing their best, but I mean, we're doing the best as we're doing the individual survey as well. So I think unpacking is where we need to go, and that's exactly what Jenny and Joel are working on, and that's why we should be a part of it. So Terry, what I would say is you should sign up for that, right?
Good
Jenny?
answer.
Very good. All right, so who, I think Cindy had her hand up for a while here.
Actually, I wanted to go back to Anne's question. Because I think no matter what we teach in our program, we are very reliant on what comes before, what prerequisites come for each of our courses. And it might be really good for each of our programs to do what are the prerequisites we have, and do they really support where we're going? And maybe they fill in a hole. So you could just have a prereq list and then go forward with your own program. So that might be more difficult to do to get. I mean, if it's hard for our own faculty to do this, imagine going to biochemistry and say, hey, would you map out what you talk about? So, but I think it's a great idea.
But I would just say some programs may do, like I know we have all of our bio and chem classes mapped to the MCAT, and it identifies specific concepts, and they've gone through and mapped specific courses to those concepts. So there might be resources available also that are in a different framework potentially, but I could see where if I couldn't convince my biology colleagues to do it, I could probably look at the work they've already done to map their curriculum to, MCAT 2015 and say, okay, these 6 things fall into this core concept. So, by, what is that, transitive property? I'm going to say they, fall into that. So, but yeah, I think that the prerequisite thing has to be considered.
Right.
So I wanted to add a comment as a course director over a team taught course, and it's divided by systems. the type of teaching interaction from each of those teachers is very different. It's really challenging for the students. So I can see that the core concepts idea would be a real anchor between the systems, but getting the buy-in from the faculty to do this is going to be a particular challenge. It was verbalized by a few people, but I see the survey as being the vehicle, the tool that aligns everybody to say, hey, we're already doing this anyway, and it opens the door to say, so this I see as the solution. Even the data is good for you and good for us, but I think more it's a vehicle to align.
And to me, that was what I learned from it, and that's why I got excited about it, because the reaction, it was, we've had a faculty member who's been doing this his whole, since I've known him, Dr. Wright, Steve Wright, and he's been just constantly teaching students and saying, when I see you down the street or you're my nurse in the future, I want you to tell me, is sodium high inside or outside of the cell? And what is which way is sodium being pumped by the sodium potassium ATPase? So some key things that to him are, so if I'm going to ask you this question and you don't know the answer, you cannot be my nurse. I need to get someone else. So he was so excited to hear, but I'm not sure. I think a lot of us are focused on other things and not necessarily. So that discussion I thought was good. I got a lot of positive feedback from individual faculty saying, "Oh, this is great, and I'm gonna use this." And it really is. It may just be a tweak that you do to your course where you just add that and you say, "Here's what I'm teaching you. Here's the concept," and I keep repeating this concept and just coming back to it. I think resistance decreases when you have this self sort of. It's self-reflection. You realize, oh, I am doing a lot of this.
I just had a question, comment about some of the stuff that's gone around, especially around the ligand issues. The conceptual framework and even the unpacking of them is really set in a larger context, but I think we need to be better at that. So I would still send that information. A few people have mentioned it to Joel, because we need to flag the work that's been done at ASB&B, because in ASB&B, when they have their core concepts, they're not calling it unpacking, but they're basically doing a similar thing. They've unpacked that in what they call molecular structure and function and macromolecular interaction, and we need to link that to there and say, we didn't do it here because it's done there. Similarly, energy and matter is important to physiologists, but the Michigan State group has done a ton of that. And so part of that too is that there's all this other work that's hard to know about, and that stuff I think that I need to help you guys get up on the PMIG side, because other groups have been working on other core concepts like energy and matter and gene flow and stuff like that.
That's very good. Yeah, the resources are really important.
Yeah. So this is actually one of my the interesting problems in my head about this is, right, like energy is common, right? Like the bio people, the biochem people, right? It's in all of those things. It's in our system too. But it goes back to what was raised earlier, is like what makes a physiology major, like, right? All of those things are part of biology and life sciences in general, but like we're still trying to figure out like which of those things, right, are not common, right? Like what are the things that we really need to drill down on if we're going to be a physiology major, right? Like what's common and what's been done in other courses, but really what makes us unique too is still something that, like, how do we tease that out? Because a lot of this is common, like the 5 things from Vision and Change, right? Biology, things like those are all things that we're talking about here too. But why is a physiology major? Jeff, you brought this up earlier too, right? So it's still one of those pieces that, like, when we're writing our focus on core concepts, like what are the things at the chairs meeting, homeostasis, right? Like that was the thing that makes us who we are, right? That was what came out of the chairs.
One
meeting,
of the groups came up with homeostasis is the
As
most
the only
important
one.
concept that should matter. Yeah, and you can make an argument for that.
I have a question about your definitions. Do they help or hurt? So I can see that they're necessary to try to get some level of consistency, but I'm still hung up on evolution. I mean, I come from Kentucky, the Home Recreation Museum. Why wouldn't I be? So I'll just leave it at that. But I still can barely deal with driving past it when I go by the freeway to the airport. So for example, I would use gene expression, for example, All right, I'll use Nick's his narwhal and the fact that the lungs collapse and so on, and they've adapted that way. I would call that evolution. Okay,
Right.
Yet others, or gene expression in different environments,
Right.
etc. To me, that's evolution. But to others, it may not be. So I need to know. I mean, do you think it helps or hurts, or is it?
Well, I'm going to turn it over to Jenny because I think that's her work, and yeah.
The definitions in the 2011 paper were Joel and my amalgamation of what we heard from physiology faculty. So it wasn't meant to be kind of a dictionary. It was really meant to be a reflection of this is what people told us, and this is what we agree that we think people told us. But it isn't necessarily the best, so I wouldn't take it as a kind of ironclad definition. It was really just reporting those faculty survey data. But I do think that the evolution piece is interesting, but it does reflect the fact that many of us, our major pedagogical tools, we are handed a textbook. And evolution isn't explicitly covered in most textbooks of physiology or anatomy and physiology. So it is something that we don't recognize as being there. And it's that I find interesting. But that's where those words came from.
So I'll just make one comment. Claudia and I were facilitating a core concepts workshop at the ACDP meeting, and we actually ended up getting the definitions out. Like we started the workshop with just the terms, and people were like, well, what does a flow down gradient really mean? And we actually really needed those to anchor the discussion, right?
That's right.
It helped
yeah.
focus.
So
where
when
we
you
were going.
don't have them, you need some guidance, I think, and especially because the words can be. You go, what is flow down gradients? What do you mean by that? So I think it's really helpful to see that. Yeah. Okay. So I'm going to turn it over to Erica for our next segment for discussion.